Hi, my name is Rishabh and welcome to section 2 of LangChain. In this section, we are going to learn two new concepts. One is called Output Parsers and second one is called LangChain Expression Language, also called LCEL. But before going there, I want to first recap section 1 with you. So, in the first section, we learned what are prompt templates and how we can create them with some dynamic variables. And to create prompt templates, we use message objects such as system message, human message, AI message. So all the inputs that we were giving and the output we were expecting, we were dividing into different message objects. From prompt templates, we generated prompts by invoking some values into the dynamic variables, and we were sending these prompts along with the chat model to communicate with the large language models, right? And so basically, the example we took in the last section, we took one of the system messages as well as the human message as input, and we gave to the large language model. And we were expecting an output as an AI message. So these are the short forms I'm using. SM is system message, HM is the human message, which were both the inputs, and AI message, which was the output. Can just give an input prompt to our large language model and expect an LLM output. So we can do that. We can simply give an input and expect an LLM output without classifying into different message objects if we don't want to have an AI conversation with it. Now let's go to the notebook. Here I have set up the basic environment, which we already covered in the last section. I have installed LangChain Core, LangChain OpenAI, reduced the version of HTTPX to 0.27, and set up the OpenAI API key. Also, I have defined chat OpenAI object with GPT-4o as a large language model that I'm going to use. Now, in order to prompt a large language model without message objects and just a simple prompt and expecting an output is quite easy. You can say response is equal to model.invoke, and then you can enter your prompt, whatever you want. I am asking at this moment, give me a list of 4 tourist locations in Chicago. A simple prompt as a text, and let's see what is the response that I get. And here we get a response. And in a very similar fashion, we can convert this prompt into a prompt template and then create a prompt out of it and eventually call the large language model again. Let's see. For this, I'm going to import prompt template from LangChain Core prompts. And here I'm going to define a template this way. Look at the difference the way we did in the last section. In last section, since we were using message objects, we were generating prompt templates from the chat prompt templates object and then converting into a prompt template. Here we are directly defining prompt template, and then we are going to create a prompt out of prompt template by invoking the values of city and the number. Here, city, I'm calling it as Chicago and number as 4. And finally, we are invoking the model with the prompt. Here we get the response. So this is one simple way of calling a large language model with a simple prompt without using message objects. So text as output. But while communicating with large language models, we don't always need output as a text. Sometimes we need output in a different format to be able to be used in different applications. For example, a JSON object. Sometimes it could be the Pydantic object in Python, or maybe as a CSV. We don't always need text as output. One way to go about it is to go into the prompt and tell the large language model that we expect our output to be a JSON object and then define a schema within the prompt itself. It works well when you have a very simple structure, but as we go into the complex structure, it's very hard to tell the large language model what kind of response you want. And the answer is not very reliable all the time, especially when you are using in software engineering application. If you are not getting your answer reliable, it's very easy to crash your app, whether it's a web app or a mobile app. So LangChain offers us a tool called Output Parser, which helps us to extract the information from the large language model or to extract the output from the large language model in a specific format. So every time we given input to a large language model as a prompt, right now we're just getting output as a text, but we do have other options as well, such as getting output as an XML or a JSON object or a Pydantic object or a CSV, right? So we are going to use output parsers with LangChain. That's what we are going to see in our next section. Let's see now how can we query a large language model and get a structured output in return. So I'm going to take you to my notebook again. I'm going to import chat OpenAI. I am going to define a model with chat OpenAI, and I'm going to use the model GPT-4o, and I'm going to invoke the model. And the prompt that I'm giving right now is give me a tourist location in Chicago. A simple prompt. Let's run it first. And here's the output that we got, an AI message which has a content called Chicago is a vibrant city with a wide variety of attractions. And you see it is completely unstructured, a lot of text data, which came as an AI message. Now, how can we structure that? So first thing that we're going to do is we're going to import Pydantic library, and we're going to import two things from the Pydantic library. One is called base model. The second is called field. And what I'm going to do, I'm going to define a class called location. So location class, the name location is something that I gave it to it. You can give any name to the class as you want, but it should inherit the base model of Pydantic library. So basically we are defining a data model here. Second thing is, while defining the location model, I'm using name description and time to be spent, and I'm using field to describe what they are. Here the description is very important because it is going to be used by the large language model to fill the values within the name, description, and time to be spent. And once we have defined our location class, what we're going to do is, after the model, we are going to use the class called with structured output. And as an argument, we are going to pass the class that we defined called location. Let's see. And here we get an output with the location object with a name called Millennium Park, description, and the time to be spent, which is 2 to 3 hours. Perfect. So I'm going to I hope the model and dump will be able to print it in a form of a dictionary. So we got a dictionary as an output here. And what if I need a list of locations? So I don't need one location, but multiple locations. So let's try, give me, instead of saying a tourist location, 5 tourist locations in Chicago. And let's run that. Here we go. Instead of 5, I've only got one output, which is Millennium Park again. And why is that so? Because when we are querying the large language model, we are asking for 5 locations. So it is returning back the 5 locations. But the problem here is that when we are saying structured output, we are defining the schema called location or data model called location with a Pydantic, which is for only one location, not for multiple locations. So if we need multiple locations, I'm going to define another class called location list, or maybe locations list. And I'm going to inherit it from the base model again. And I'm going to say location, which is a list of locations, exactly this. I'm going to define it as a list of the location model with the field list of locations. And I'm going to pass this location list here, and I'm going to run this again. Here we go. So in return, we got a dictionary which has a locations key, which contains an array, and that array contains 5 different locations within Chicago that we can use as a tourist spot. We can further modify it to show only the array. And here you go, an array of 5 locations structured exactly how we wanted it. Perfect. Now let's see how can we use prompt templates with it. I'm going to import I'm going to make the number of locations as variable and city as variable. We are going to define a prompt template variable here. And then I'm going to create a prompt from the prompt template. I'm going to keep the number as 5 or maybe 7 now. And I'm going to invoke with the prompt. And let's see what we get. And here we go. We have 1, 2, 3, 4, 5, 6, 7 different locations, all structured in proper format as per our Pydantic class location. So here we were able to create a structured output while interacting with the large language model, while giving a simple prompt or making a prompt out of a prompt template, right? And here we are, because using the prompt template, we were calling the city Chicago and number 7, but we can use different values for the city as well as the number 7. But here you see the last 4 lines. These 4 lines are very inefficiently written, I must say. So we are defining something as called prompt template. It stays fixed, but every time I want to change the city and the number 7, I need to redefine the prompt, and then I need to put that prompt into the model, and then model is going to need to be invoked again. Then we get a response, and then we are going to dump that response basically, right? There's this lot of repetition of things. So basically prompt templates to prompts, then prompts to the model, and then getting the output parser. So basically inserting into the output parser and getting the response. Not very efficient way of representing the code. So that's why LangChain provides us something called LangChain Expression Language, which basically helps us write this chain of values while moving from prompt templates and invoking it to prompt, and then moving from prompt to getting into the chat model, and then from chat model to going into the output parser. So this, it helps us create an efficient way to write this chain and invoking it again and again. So I'm going to take the same example, but write it right now with the LangChain expression language, which you will see is much more efficient way of writing the code, the same code that we have written here. Now here I have written structured output with LangChain expression language. So I'm going to start with defining a model. So I have imported chat OpenAI and I'm using GPT-4o, and I've defined a model here. The next thing I want to do is I want to import the classes that I need. So I'm importing the prompt template as well as base model and field from the Pydantic library. The next thing is I'm going to define the classes locations and locations list, the same thing as we did before, precisely the same. One thing that you need to note is that in the last example, while defining the model, we used chat OpenAI with model GPT-4o, and we chained it with structured output and passed the argument locations list. We are not doing any such thing in this example. We are going to simply define the model, because when we are going to use the LangChain expression language, we're going to pass the output parser there, and we are going to see that. Now, next thing I'm going to do is I'm going to define my prompt template. So I'm saying prompt template, where template is give a list of number tourist locations in city, where number and city are the variables. And I have added a separate argument input variables, where I'm defining the input variables that we are going to use in this prompt template. So I'm clarifying this within the prompt template, that which are the input variables. We haven't done this before, but we are doing this here because of one specific reason that I'm going to talk about later. Next thing is I'm going to import JSON output parser. So the output that I'm expecting right now, I want it in a JSON format. So that's why I'm going to import something called JSON output parser. So I'm going to define a parser with the help of JSON output parser. Variable parser is the JSON output parser, and I'm passing at the Pydantic object that I have defined, which is a location list. And next thing is I'm going to define a chain now. Now this is the chain which is defined using LangChain expression language. Here we are having a prompt template, And then we have this operator defined by LangChain Expression Language, which basically means that the output of the prompt template is going to be the input of the model. And again, I'm going to use this, which means that output of the model is the input of the parser. So basically, we have defined a chain where we are not invoking it with any values till now. So we have not provided any value of the city or the number that prompt template needs. We just defined a chain where we're saying prompt template, we are going to invoke it. And when we invoke it, its output is going to pass to the model. And the output that we are going to get from the model is going to be the input of the parser. The next thing we are going to do is we are going to invoke this chain with the dictionary where we are assigning the values to the number, and let's see what kind of response we're going to get. Now, if I try running this, now we find that there is an error, and this error is expected because in the chain, we have defined prompt template, then we are querying the model, and the output of the model is we are passing to the parser. And parser is our JSON parser, which should be able to convert our response from the model into the pydantic class that we defined here. But to be able to parse the output of the model should give a response in a certain format, right? In the previous example, we said with the structured output, which guaranteed us expected output of a model in a certain format, which goes with a pydantic object. But here, to ensure that we are getting the right response into the right format, we need to give our large language model explicit instructions that how the output of the model should be structured when we are querying it so that we get the response. So we can basically say or define here that we need our output to be in format, and we can say name, and we can say description, and we can say time spent, something like this. We can do that, and of course there will be single quotes, otherwise it will conflict with the external quotes. So but basically we can do that, but something not recommended, because this is not a very reliable way of passing the instruction to our prompt template or to our prompt or to our large language model, because in a very simple structure it might work for you but not very reliable. And as the structure of your output gets complex, it's very difficult to write the right kind of prompt for your large language model to give a response in a very specific or structured way. But to ensure that, you need to write a very strong prompt, and LangChain helps you write the right instructions and the prompt for your large language model to get an output in a very structured manner. And what we can do here is that we will first get rid of this, and we can define another variable here along with number and city called format instructions. Now, what format instructions is going to do? It's not the same variable as number and city. Number and city are dynamic, and they can change again and again every time we are going to use it. But format instructions is a partial variable. What a partial variable means that it is gonna have a value given to it by the code that we have written here and by with the help of the pydantic object. So it's going to take a value with the help of the pydantic object within the code, and the variables or input variables number and city are dynamic, and we are going to give those values at the runtime. Whereas this instruction or this value is not given by us. This partial variable value will be given by the LangChain before after we run the code. Now, next cell, we are going to define partial variables here, and we are going to give a value to the format instructions right here, and the value for it will be parser.get format instructions. So this is a method in the parser object that we defined here, the JSON output parser, where we say get format instructions. So basically, LangChain helps us create the instructions that we need to provide to the large language model so that we get our output in a certain format every time, and we can rely on that. Now let's see what exactly this parser.get format instructions method put the value in our prompt template. For doing that, I'm going to add a separate code cell and I will try printing it. And you see what I get. The output should be formatted in a JSON instance that conforms to the JSON schema below. And it has all the instructions, proper instructions, or I should say a proper prompt that is gonna be inserted into our prompt template or into our prompt here, exactly here, which is going to tell our large language model with other instructions that how the output should be formatted so that the output of this model can go into the parser and the parser can parse it into the JSON format. Let's now run the main cell here. And here we go. Here we get our locations object and we get an array which contains 7 different locations. I hope I was able to explain you how we can define the chain using LangChain Expression Language and how can we efficiently write the code to invoke it again and again with different dynamic values. Thank you. Told you that in the last section we were using message objects to communicate with the large language model. But in this section, all the examples we have taken, we have not used message objects. We simply write a prompt, given the input to the large language model and receive an output. Now, let's do an example where we are taking message objects and then communicating with the large language model. And let's see how it differs from the last example we did. Given the heading message objects, output parser, and LangChain expression language, we're going to see the fusion of all 3 of them. If we have to use them, how we are going to do them. First of all, I'm going to import all the basic things that we needed. I defined the identity class, the locations, and the locations list, same as before. And I also defined the model, which is a chat OpenAI, and I'm using GPT-4o. Next, I'm going to define the system template or the prompt template. And again, we are going to use here, you see in the last example, we used prompt template directly. Here, since we are using message objects, I'm going to use chat prompt template. And based on chat prompt template, I'm going to generate from the messages, from the system message and the user message, I'm going to generate the prompt template. And once I've done that, I'm going to define the parser. So I'm again going to use the JSON output parser. And I'm going to pass as an argument the location list. Next, I'm going to define the chain. Chain is going to be prompt templates, model, and finally the parser. And then I'm going to invoke the chain with the values. And here you see in the template itself, I have the format instructions. And to pass the value of format instructions, now this time, instead of passing the value from the prompt template, just like here, we directly pass the value here. Optionally, you can pass the value for the format instructions here as well while invoking the chain. And in this case, I'm doing the same. I'm passing the format instructions and I am invoking the value of format instructions while invoking the chain itself. And let's see what we get. Perfect. And the region we are serving is Middle East, days is 5, and city is Dubai, along with the format instructions. And we got our output in the proper format, you can see here. So it names the different locations for the tourists to visit within Dubai. Thank you. So till now we have seen how to use LangChain expression language to write the efficient chains where we are using the prompt templates and how to invoke prompt templates. We also saw how to get a structured output with the help of output parsers and where we define different pydantic objects to get the output in a specific format or a structure. And with the help of this knowledge, we can solve a very different use case of something called classification. So classification is where when you tag a certain thing with some predefined values, or you give some rating or range to some predefined values. Maybe take an example of sentiment analysis. You are getting a lot of posts or you're getting a lot of text and or messages, and you want to filter out the messages which are positive and you want to filter out the messages which are negative. For example, you are on YouTube and you upload something on YouTube, and based on that video you get thousands of comments. Now you don't want to see all of those comments, you want to filter them out. You want to see which of those comments are positive and which of those comments are negative. And basically, you're classifying your comments that you're getting on your video, whether they're positive or they're negative. So you are basically classifying them into different classes, positive and negative. And you don't have to stay with either positive or negative. You can classify them even further. Which of those comments are of appreciation, which of those comments are abusive. Same thing you can apply with your emails. For example, if you have used the app of Gmail, you get a lot of emails, but all of those emails are divided into different sections, at least for me. So I have a section where I get all the promotional emails. There are another section which I get all the primary emails of which are important. And then there are some emails which are social based, right? And so they're classified into different sections. And same thing you can do with the help of LangChain and based on the knowledge that we gained till now. So now we're going to take an example and we're going to put an input to a large language model. We are going to start with a simple line and we are going to rate it on three things or classify it based on three things. What is the language of the text that we have given to our large language model? Second thing is what kind of sentiment it has. And third thing is what is the aggressiveness level like? Is it very aggressive or very low aggressive? And we are going to put it on a scale between 1 to 10. So I'm going to give it a heading called sentiment analysis and some basic classic classification problem. I'm going to start by importing all the libraries and I'm going to define a model, chat OpenAI, and I'm going to say it's a model GPT-4o. And then I have defined my prompt template, and this time I've given it a name called tagging prompt. So basically, what I'm saying is extract the desired information from the following passage. Only extract the properties mentioned in the classification function. And passage, I'm going to give it an input, and then I'm changing the line. Sorry, I'm changing the line, and then I'm giving it format instructions. And here I defined my Pydantic object with the name of classification, which inherits a base model of Pydantic. And I'm going to say it first thing as sentiment, which I expect to be a string, and I want the sentiment of the text. Now here you see I haven't defined what are the possible options for sentiment, something we are going to do later on, but for now I have just mentioned I want the sentiment of the text. Then the next thing is aggressiveness, and I expect it to be an integer, and I'm saying how aggressive the text is on a scale from 1 to 10. And at the end, I have language, and it is of, I'm expecting a string, and I'm saying the language the text is written in. After that, I'm going to define the parser, and I'm going to use JSON output parser. Finally, I'm going to define a chain where I'm saying tagging prompt output go to the model and model's output go to the parser, right? And in the simprint block, I'm going to invoke the chain and I'm going to give it an input. I feel guilty of hurting you. This is the text I'm going to give it as an input. And I'm also passing format instructions from the parser, which is get format instructions, right? And I'm going to print the response here. Now let's try by running them. Okay, I got a negative sentiment and aggressiveness level is 2 out of 10 and the language is English, which is not bad. Let's change the input. Let's run it. So sentiment is happy, aggressiveness is 1 and language is English. Now the next one, I'm going to take in a different language. I'm going to use Hindi here. And basically I'm saying you are an idiot and I don't like you. Okay, let's see what kind of output we get now. So language is Hindi, which is right. Aggressiveness is 7. That's true. And sentiment is negative. Okay, one more thing. One more try. sentiment, sad, aggressiveness, 1, and the language is English. It works very well. But there's one problem into this. This value of sentiment is changing rapidly, and we haven't defined the possible values sentiment can take. Aggressiveness, we have defined 1 to 10, and it works pretty well. And then the language itself, we don't really need to, but I feel like I need to know the possible values of language that I want to put, that the kind of input I'm giving. Sometimes we know what kind of input I'm giving. So I need to have a little bit control over what possible values sentiment can take and what possible values language can take. So let's see how we can have a much finer control over this classification. I'm going to make a slight change into our pydantic class of classification. I'm going to provide something called enum. And in the enum, I'm going to provide all the possible values that sentiment can take. For example, I'm going to say happy, sad, and neutral. The only 3 possible values that our sentiment can take, and I don't want any third or a separate value which is not mentioned outside this array of enum. I'm going to change a little bit of description for the aggressiveness just to make you understand the example more clearly. How aggressive the text is on a scale from 1 to 10. Something like this. And I'm going to provide an enum value here, which is going to be 1 to 5. And let's say the language here, I don't really need to, but just for the sake of example, I'm going to provide it a value of possible values. And here it is. So I'm expecting Hindi, English, or French. And if I get anything else, I'm going to show unknown. So these are the possible values that language can take. These are the possible values aggressiveness can take. And these are the possible values sentiment can take. Now let's try running this. And here I'm going to run that. And I got sad, and it was sad before as well. And here, instead of saying sad, let's say negative. And let's try running this again. And here we got negative as the answer because I changed sad to negative. And let's say I'm going to change the language, Chinese. And if you see, I don't have Chinese language within this array. And if I run this, I get the language as unknown because it doesn't fit Hindi, English, or French. And aggressiveness is 4, and the sentiment came out to be negative. So here you see I have much finer control over our sentiment analysis problem or this classification problem. And here I can tag my input based on aggressiveness, sentiment, and language. I hope it is clear to you. Thank you. I hope with the help of this video, I was able to explain you output parsers as well as LangChain Expression Language. If you find value in this video, please consider liking, sharing, and subscribing. Thank you.